Good morning, everybody, and welcome to ARC's second web window. My name is Anne, and I will be moderating this session today. It will last around 60 minutes. Just as a small throwback, maybe ARC has started 2015's first quarter with Industry 4.0 and big data, and today we would like to go ahead with machine safeguarding and energy management. My colleagues Thomas Menze and Florian Güldner will present some of the overall trends for machine OEMs and will make a deep dive into these two distinct topics. At the end of the presentation, you can stay further 5 to 10 minutes online and ask questions if you would like to. And now, without any further delay, I would like to pass over the word to my colleague Florian. Florian, can you hear us?
Yes, thanks, Anne. Hello also from my side, and welcome to this web window on machinery topics. We will start right away, and our first topic is the outlook, where we'll discuss the overall development of the machinery market. We will then move towards the general megatrends, and afterwards discuss the machine safeguarding and energy management, everything from an OEM/machinery perspective. So what you see here is our automation index. You can see the global one in the top left corner, and the discrete and process automation index on the back in the lower part of the slide. What you also see is that in the process as well as discrete industries, the automation index contracted in the last quarters, and that's the bad news. The current market environment is rather gloomy. We do expect a cool down. We do expect a contraction of the market over the next months. In Europe, we feel negative impacts from US and China. China is really slowing down. We expect only between 2 to 4% growth over the next 2 years, which is basically nothing for China. And also the US, we see that while markets that are close to the consumer benefit from the low oil prices, many other markets are affected negatively. And what we also see right now is that the monetary US, meaning that the central banks have basically used all their measures that they have available, from low interest rates to supporting central banks to really having a very expensive monetary policy such as quantitative easing, and now there is not much room for further improvements. How it seems right now quite likable Brexit will affect the market is unclear. The direct impacts will be very, very small, but the indirect consequences, meaning the effect on the euro, the stock exchange markets, as well as other investments, that can be very big, and this is currently a big question mark. In this environment, we still expect a CAGR of 4 to 5% until 2020. This is good growth, but it's also significantly lower than the long-run CAGR that we have from 2000 to 2008. So it is an overall slowdown in the long run of the market, and there are various reasons for that. I will explain some later on. What you see here is a preliminary excerpt of our machinery study. You see we clustered it into basically 3 product groups. We have sensors, which includes proximity sensors, photoelectric sensors, as well as vision sensors. We have drive and motions, consisting of GMC, CNC, and low power drives. And we have the control area, where we talked about IPCs, panels, PLCs, etc. Overall, the largest group is the control group, and we expect the highest growth of these product groups in the sensor group. Now turning to megatrends. So the big trends that we see across all markets, that we could see across all regions, that have really a global impact and also impact the machinery market. To talk about these is, well, people get very enthusiastic and very optimistic talking about these megatrends because they see the opportunities in them. But we have to point out before we get into the detailed discussion that especially in the short and mid-run, the business cycle has a far bigger impact on the development of the market than these long-run trends. They have the potential to increase the development, increase the growth, but in the short run, if the economy turns down, if the business cycle is down, long-run trends simply are overshadowed and do not matter. The first trend here I would like to talk about is the Industrial Internet of Things and Industry 4.0, which really means that we're talking about connected machinery, we're talking about intelligent devices, and we talk about modular plants and automation. So these three really go together. For the OEMs, this really means that all the devices need to be able to collect and pass on information, to have a good network infrastructure in place within the machinery, and to somehow enable this plug and produce as necessary. For us also, these three trends and some other are all pushed by an underlying dynamics of the consumers that demand more and more customized products, and we also see the more and more smaller and shorter product life cycles. So all these trends are here basically able to increase flexibility while maintaining or even increasing productivity and profitability. We have a big trend that impacts the machinery, that is big data. Right now, for example, in energy management, data is not really collected within the machinery. This is often added later on, but in this complete new framework of Industry 4.0 or the Industrial Internet of Things, machines need to be really able to communicate with upper layer automation systems such as HMI and MES. And this goes hand in hand with the next point, like cloud computing and service-based solutions. We currently really see that business models are changing. OEMs such as you, paying models, it's more service oriented, there is more money in the service than it's in the selling the machines. And together with the data and connectivity enabled in future, this really can offer tremendous opportunities and completely new business model. I last want to really point out or talk about the additive manufacturing and 3D printing, because this is a technology that could really have disruptive impacts. Additive manufacturing will replace some part of subtractive manufacturing as we see it today, especially when we talk about laser sintering and other possibilities. So this has really the potential to really impact the market in various ways and can be a real game changer, especially when it comes to producing spare parts and it's producing really small batches. Now, I want to talk a little bit more about a trend that we see for around, well, 3 to 5 years now, and this is modularity. What you see here is part of basically a process plant. It could be a pharmaceutical, food and beverage, it could be chemical, it could be a lot of different applications, but it's some sort of packaged units, as it's called. And this means you basically have a plug and produce system which will change the way process industries such as the chemical industry will produce. It also means that we face a couple of new requirements for control. Scalability, if you have really modular production, scalability is required on a completely new scale. Also, the communication really needs to go down to the individual sensors and valves as you see it here, and this from a real centralized control station. we're talking about new requirements from the availability, here in parentheses, mean time between failure. This means the uptime really needs to be guaranteed. Machines also have availability or guaranteed uptime as very important criteria, but looking at process industries which are capital intensive and hence do require 24/7 production, availability becomes a completely new dimension. We talked about integration, and here it's important to talk about three things. First, everyone talks about the control equipment and the integration there. This can be done pretty easily, to be honest, but the hard part is to really standardize and integrate these small devices, the pipes, the diameters of the pipes, and also the heights, width, and lengths of these modules to have a plug and produce interface. And the last part of integration is really the integration with the backbone. These package units are also modular machinery, as we have seen it at the Hanover Fair, do require a supply with gas, power, water, nitrogen, compressed air, etc., etc. They won't produce them by themselves, so they need also have a standardized interface there. And this really bears completely new challenges also for energy management. And while current machinery for the discrete industries do have a lifetime of, on average, between 8 to 12 years, these package units will be having a very long life cycles, up to 20 years. And we talk about very specific requirements such as alarm management as well. Now, looking at these megatrends, we did a survey and asked around 400 people what impacts the buying decision on PLC or PLC-based packs. And what you see here on the vertical axis are the buying criteria. The most important was lifecycle support for hardware and software, and the lowest was integrated energy management. On the horizontal axis, you see the options we gave the respondees, ranging from no criteria to most important criteria. I want to point out really two things. And the first thing is a lifecycle support solution offering engineering tools. So this also means that the top three criteria have nothing to do with cycle time and with scalability, and because especially looking at PLCs, these controls have reached a level where they can basically consider to be a commodity regarding hardware. The differentiation now, it's really about portfolio offering, about solutions, and the software and support delivered with the controller. Second thing I want to point out, so if we're talking about that now, is the aspect of integrated safety and integrated energy management. This seems to be not the most important criteria, and this also, from our interpretation of the data as well as with additional interviews, we see these two criteria as being really emerging topics. So while some machine builders don't even think about integrated energy management or an integrated safety because they consider this to be part of the end user and system integrator to enable that, this will become more and more an issue for the OEMs and also will create more and more challenges, as well as the potential to differentiate and be that one critical step ahead of the competitors. And with this, I would like to hand over to my colleague Thomas Menze on the topic of machine safeguarding.
Yeah, it's my pleasure to talk regarding machine safeguarding. So thank you, Florian, for the introduction. And let's start with really a basic question, because my intention is to have all participants know a common understanding. And next slide, please. The most important question is really, what is functional safety? And if we are talking or discussing a functional safety, it means we are talking regarding the safety relevant components of a machine control systems. And these components have to meet the intended reliability and the risk reduction of the machine itself. So this is really what we call functional safety. We are talking regarding the safety components. And please keep in mind, safety-related components quite often contain hard and software at the same time. So in some cases, hardware is good enough, but the normal standard is you have a little software around to control the safety functionality. So what do we have to do to implement now these safety-related parts? And therefore, we need the next slide, Florian. And on this slide, you can see on the left-hand side how to implement the safety functionality. And this is shown in this little process diagram. So you have to do first a risk assessment on your machine. And if you have done or if you understood and evaluated all risks involved, then the second step is really design a safety concept around these identified risks. And third, and last but not least, is really verify the safety function. So you have to really verify that the implemented safety is good enough to keep the risk under control. And on the right side of this slide, you can see a full safety-related component portfolio that is the sensor, the logic, and the actuator. So if people talking regarding safety components, you have to keep in mind this is always, let's say, a loop, and this loop normally contains a sensor, a logic, and an actuator at the end, because this loop is really responsible for acting the safety commands and doing the right things if any risk occurs. So coming to the next slide, Florian, we have to think about what are the standards. Are there any standards, or do we have to develop everything from scratch? And the good answer here, no, of course we have standards and framework. So safety standards normally provides a framework for the implementation of the safety functionality. And don't forget, if you work on safety, safety has to be implemented over the full life cycle. It is not only the normal operation mode of the machine, so you really have to observe and do the risk assessment over the full life cycle. And you get a little guidance in these three available standards. These three available standards are differently oriented. So we have an A, B, and C standard. Normally the B and C standards is really the important stuff for the machine builders, because in these B and C standards there are the typical safety applications for given machines. So you have, for example, typical safety aspects in the B standards, or you have really some real examples of machines in the C standards. So if machine safety is quite new for you, so best is refer to the B and C standards to see what's in for your machine type. Okay, so if the standards are under control, we need a global view if our machine is really delivered around the world. And therefore, next slide, please. Okay, here you can really see what's happened if a machine supplier delivers a machine to the global world. First, we have to look on the left-hand side. There is one diagram where you have really displayed the different safety levels. Here are the SIL, these are the safety integrity levels, and the PFD, these are the probably failure on demand indicators. And how they related to each other. Good news is SIL 4 does not exist in our industry. SIL 4 is only required in nuclear applications and sometimes in train systems, but you will not find SIL 4 in normal machines. And if we check the right side of this diagram, you see the different regions of the world. And you see they require really different aspects. So sometimes the manufacturer or supplier is responsible for the machine safety, sometimes the end user, sometimes both, and in other parts of the world, sometimes the employees. So that means really people who are acting or interacting with the machines are responsible to make sure that machine safety is up and according to the standards. Machine safety is really does not add any productivity. It is really adding safety to the process, and this is shown on the next slide. So Florian, please flip over. And here you see on the right-hand side a little scale. And you see safeguarding is there explained as a balance of lifeguarding, productivity, and costs. That's what I said earlier on. So it is really, you only get safety if cost and productivity is right balanced, and if you have done the right risk assessment, if you really engineer the machine itself, and the safeguarding scope, the products or segments of safety aspects are shown in the left-hand table. You see all the basic components, for example, from top to bottom, the safety PLC, the configurable relays, the safe drive, the safety relays, and so on. So these are all the components the engineers or the automation people normally have to get the machine safe. So I think that should be now enough for the introduction. Now we are discussing really the market itself, and therefore we need the next slide, please. So here we see really the machine safeguarding applications by SIL levels. And if we check here this overview, we will find out applications like robotics, forming, or assembling require SIL 3 protection, because simply the risk is higher. So if a robot, for example, has a collision with a human, that is normally very painful for the human. Because of that, he can be really seriously injured. The risk is quite high, and because of that, the required SIL level, so the safety reduction level, is high. Packing machines, material handling, or molding machines require SIL 2 only, because the risk going out from these machines is lower. So these different risk levels really depends on the risk evaluation. So you have to do the determination, you have to analyze the machine, and you as an engineer have to determine what risk reductions is required. Okay, if we dig a little bit deeper into the market and discuss the driver and inhibitors, therefore we need the next slide, please. We will find out that there are definitely drivers of these markets, and that is what Florian said earlier on, so higher productivity. So at this moment in time, nearly every engineer tried to get more productivity in the machine. So it runs faster, it turns faster, whatever. Because of that, there's maybe more risk in the machine, and this higher productivity gains a higher risk and higher requirements according machine safeguarding. This modular automation does the same thing. Florian explained modular automation in the first slides we discussed. And of course, if you assemble a production on the shop floor like a Lego style, that means you have little production blocks and you can plug and produce those on your shop floor. There is maybe a higher risk level, so that is definitely a driver for machine safeguarding. And last but not least, that is the last bullet point on the left-hand side, safety standards. So the safety standards are from time to time increased. There must be more safety in the machines, and because of that, we have to implement more machine safeguarding. And that is definitely a driver for the overall market. So if we observe now the market itself, therefore we need the next slide. We will see here the total machine safeguarding market from 2012 up to 2017. And definitely the overall market has a higher growth compared to the normal automation products. But please keep in mind, machine safeguarding market represent roughly 10% of the automation market. So it's a fast-growing market, but on the other hand, it's a niche market and relatively small compared to standard automation market. So if we analyze really the individual products of these markets, we come to the next slide. Here we are, and we see there's a machine safeguarding installed base. And if you analyze these little graphic a little bit deeper, you find easy out what are the volume products are. And the volume products are really the operator interfaces, the safety switches, the safety relays, and the light curtains. So these products are really the driver in this market, and they deliver the highest revenue to the overall market. So if we leave now a little bit the market and the products beside, and if we are concentrating ourselves on the market, we will find out that we have really different vertical market for machinery, and these different vertical markets, they have different requirements for machine safeguarding, and you see that in the graphics on our display here. And if you analyze the graphics, you will easily find out 50% of the market are absorbed by 5 vertical markets. That means half of the markets is represented by metal forming, packing, material handling, robotic, and metal cutting. If a customer or engineer really develops machine for these vertical markets, he's highly confronted with machine safeguarding. So going away back from the market and looking a little bit deeper into products, we need the next slide. And here we see the average component lifetime expectations. And now one slide back, thank you. And on these average component lifetimes expectations, you see that the lifetime of the safeguarding components are often smaller than the machine lifetime itself. And that is another driver for the industry. That means if the machine lives 20 years, but some of the installed machine safeguarding components live only for 5 or 10 years, you have to do revamps in the lifetime of the machine because of that. It is a driver for the industry because that will gain additional machine safeguarding business during machine lifetime. And last but not least, on the last slide, so next slide, here's the summary. What are really success strategies on machine safeguarding? And I think Florian discussed this more or less in his intro. So decentralized solution and intelligent technology. So intelligent technology belongs to the industry 4.0 or industrial Internet of Things. We discussed this, but the last topic, this can be quite important, is safety consulting, because safety or machine safeguarding becomes more and more complex, and many engineers struggle with that, and they're looking for third-party help. And if some experts are outside and offering machine safety consulting, that could be a very valuable business and definitely something which maybe grow very fast compared to the hard and software in machine safeguarding. So I think this should be enough for our little excursus regarding machine safeguarding, and I hand over and back to Florian.
Yeah, thanks, Thomas. Now, energy management, and not energy management as many people think of big plants consuming a lot of coal, gas, oil, etc. But what can energy management do on the machinery layer in discrete automation? And just to give you an insight first about the challenge, what you see here is the energy costs as percent of the revenues, and on the vertical axis you see the different industries. It goes from 0 to 25%, and very clear on the top industries of the energy costs are oil and gas, metals, water and wastewater, cement and glass, chemical. These are the standard process industries. And now looking into discrete manufacturing, really the top consumers, so to say, are textiles, consuming a lot of water as well as electricity. Plastics and rubber, especially injection molding machines, are very, very energy intensive food and beverage, cooling as well, cleaning with water is very energy intensive. But overall, we don't have this huge share of as energy as part of the revenue as also of the cost, which also means there is not as much pressure on the end users to implement energy management measures as it is on the top consumers here. So this is the status quo, this is the facts, but now let's see how energy management is implemented. Typically, energy management starts with a simple metering, and unfortunately, there are still many companies out there that actually do not know how much energy they consume, meaning energy in terms of water, air, gas, electricity, and steam. This is to many still unknown, as especially in the automotive industries or aerospace, it's often the facility management that gets the energy bill and not the production part. After metering, we go to the visualization. The visualization really starts with visualizing 1-2 meters at the machinery level, but then moves up to the complete production line, moves to analysis and reporting, which is already at the MES layer and has includes the management feedback. And then we go into real-time monitoring, optimization, and enterprise-wide optimization. Here it is very important on the enterprise-wide layer that it makes only sense if there are certain standards, because with these standards you can actually benchmark your facilities, or you can benchmark single processes or single machinery. For the machinery perspective, we are mainly talking about metering, visualization, and analysis and reporting. This can be supported and already done in the machinery. The latter is really part of higher level automation systems, which are typically in charge of the system integrator, EPC, or the end user. Now, we did ask also in the survey people from various industries if energy management has an impact on the buying decision, ranging from no impact to main driver for purchasing equipment. And again, you'll see that the discrete industries are at the very bottom. But maybe you still have it in mind, but what was really at the lower part on the cost side were automotive and aerospace, and also food and beverage was slightly lower. But what you see now here for food and beverage as well as for automotive, energy management does already impact investment decisions. And if you would basically average that, you would land at around 1/4 of the investment decision where energy management does have an impact. And one reason I can already tell you that here is that many automotive car makers, especially from Germany and Europe overall, do push their tier 1 suppliers to implement the ISO 50001, even though they have an energy cost share of around, let's say, 1 to 2% of variable costs. So it is not only costs that do drive energy management measures, it's more. And we asked what are the targets for energy management, and okay, the most important target is to reduce costs, but it has also to do with planning future consumption, optimize overall processes. Energy efficient process is typically overall a smooth process and efficient process. They need to optimize the purchasing and the schedule with suppliers, pass on costs. So it's not only simply reducing the total costs, although reducing costs is the most important criteria. Planning future consumption will be more and more important as we expect. Really the scheduling with the energy supplier and utilities, as even now process plants have to do load shedding in certain parts of the world. Future cost planning, energy prices are currently down, but they are still volatile, which means it's very hard to forecast your energy costs for the next month if you don't really know what's going on in your plant and how your consumption will change. And it really requires detailed measurements and deep integration. So, summary of the status quo. Energy management is and will remain a priority 2 topic. This is unfortunately a fact, and we have to keep that in mind. So, throughput, production quality, product quality, output, safety, these are all priority 1 targets, and energy management will be priority 2 target. And especially looking at factory automation, energy management is in its infancies. But more end users look into energy management. The number is really increasing despite the currently low oil prices. ISO 50001 was really the fastest adopted ISO norm that many people told me in interviews, even faster than 9001. Automotive end users pressure their tier 1 suppliers to implement the 50001. This I already mentioned. The energy costs will rise in future. Now, I know we have low oil prices right now. I know energy is currently rather cheap, but this will change. We have an indefinite demand in energy and we have a finite source on energy, though it's a very simple math to calculate that energy costs will rise in future. And we have an increasing number of end users that force their OEMs to integrate energy management right from the start. We had a few interviews with companies from the electronics industry, and they say energy is an important cost factor, and we do want our OEMs to enable us already just to read out of the machine the consumption data and not having to install the meters and everything in parallel later on. This is why we expect an overall growth of around 10% in energy management. For the industries, automotive, food and bev, and some energy-intensive industries, that growth rate will even be higher. And when you think back of one of our first slides, we do expect a growth rate of around 4% for the machinery segment. So this would be growth that's more than double. It's not an unattractive market to be in. The top regions will be Asia as well as in EMEA. We do not see much impact from North America right now. Now again, the split into the discrete and hybrid industries, and what you see here that the food and beverage as well as the automotive industries are the largest market for automation when it comes to energy management in discrete and hybrid industries. So that was it from my side on energy management, and we can come to the Q&A now.
Yeah, okay, we will definitely do, but let me first inform the people about ARC's next web window, which will cover the automation markets, and this will be hosted within the 3rd quarter, so probably in the last week of July. And further information will be sent to you as well, and we would be happy to welcome you there again. So please feel free to contact us if you have any questions or if you require any further information on machine safeguarding or energy management or whatever you would like to as well for ARC in general. And yeah, so that is all we have for today's webinar, and a special thanks goes as well to my colleagues Florian and Thomas